Limits in terms of calculus. The definition of a limit is the limit of a function describes how the outputs of a function behave as the inputs approach some particular value. L and C are real numbers. The function f has limit L as x approaches C if, given any positive value epsilon, there is a positive number delta such that for all x you have this very formalized and somewhat old-fashioned string of representations of what a limit is. Probably will not see this. Most likely it will appear like this, which is how we commonly see it today. So the limit of f of x as x approaches C is L. So the limit of f of x as x approaches C equals L. This is the common representation and the more modern representation used in calculus today. So an example. Determine the limit via substitution. So we're finding the limit of the function here. The function we'll call f of x is equal to x squared plus 2x minus 15 over x squared minus 4x plus 3. So, the limit of f of x as x approaches 3 is equal to, how are we going to do this? Well, if we simply substitute 3 in for all the x's, we'll find that we don't get a good result. We'll get 0 over 0, and that's indeterminate, and we cannot use that. So what we do is we factor the top into x plus 5, x minus 3, over x minus 3, x minus 1. So this and this are equal, just in a factored form here. So we can cross these two out because they're the same and we get 1 over 1. So the limit of f of x as x approaches 3 is x plus 5 over x minus 1. Now we can substitute in 3 to get 3 plus 5 over 3 minus 1. And so the limit of f of x as x approaches 3 is equal to 4. So the reason we can use f of x here is because we've connected it at this point up here. We've recognized that x squared plus 2x minus 15 over x squared minus 4x plus 3 is equal to f of x. So in all these in cases here and here, it is okay to just use f of x instead of rewriting this entire expression, because we've recognized and made the relationship of f of x and this this fraction. Another example. Use the graph to determine the limits and value of the function f of x, or explain why the limit does not exist. Also, what is the limit of f of x at x equals 1? So the question here isn't really all that clear about what you want to do, but we're going to go through each point and determine the limit, or if it doesn't exist, we'll mention that. So let's go through this. We'll start at -4. So the limit of f of x as x approaches -4 from the right. This plus sign means from the right. We can tell that that is -2. Limit of f of x as x approaches -4 from the left equals 3. Thus, the limit of f of x as x approaches 4 equals dne, or it does not exist, because the limit as x approaches -4 from the, as this is a negative, as x approaches -4 from the left is 3, but from the right is -2. So we know that it does not exist at -4. Okay, let's look at -1. So the limit of f of x as x approaches -1 from the right equals 4. That's coming from the right, so this way. Limit of f of x as x approaches -1 from the left, represented by the negative sign, from the left equals 4. Thus, the limit of f of x as x approaches -1 equals 4. The limit does exist, and it is 4. Okay, we'll look at 2. The limit of f of x as x approaches 2 from the right equals 5. Limit of f of x as x approaches 2 from the left equals -1. You probably guessed it already, but the limit of f of x as x approaches 2, dne, does not exist, because as it approaches from the right and from the left, there's 2 different values, and limits don't exist at this condition. So let's look at 4 now. Limit, what is that? Okay, limit of f of x as x approaches 4 from the right is 2. Limit of f of x as x approaches 4 from the left is 2. Thus, the limit of f of x as x approaches 4 is, we know that it's 2 and 2 there, so it must be 2. Okay, so now let's look at the second part of the question. So, I'll change colors. Okay, what is the limit of f of x at x equals 1? Okay. So, we'll look at the limit as x approaches 1 from the right and 1 from the left. So, limit of f of x as x approaches 1 from the right equals, so we'll go to 1 here, we'll draw a little point, and from the right, 3. Limit of f of x as x approaches 1 from the left equals 3. So, since limit of f of x as x approaches 1 from the right equals limit of f of x as x approaches 1 from the left, the limit of f of x as x approaches 1 equals 3.